Hello, everyone. So now we're going to look at day 26, 27 combined. I combine these days because if we were in class, I would teach everything to you in day 26, and then day 27, we would just spend an extra day practicing. So it's it's just the same thing. Okay. So we will look at this. Let me get my notes. Okay, pulled up here. So day 26, 27, and what we're looking at today is building a better model. So we are going to look at better models and what that means to us and what does that mean for significance and that kind of thing. So we're still in multiple linear regression. And the whole idea between building a better model is that we're hoping in the end to have this nice model of regression that only has significant predictors. So remember what a significant predictor means. It just means that that predictor has an effect on my response variable. So it actually means something to the model. So if a predictor is not significant, then we just think, well, it must not really impact the model. It must not really help the model any. And then if it's not significant, why is it in the model to begin with? Okay. But we haven't gotten to this yet, right? So we've only just looked at models and what they are and how to look at them and see if they're significant. And now we're looking at building a better model. And the first thing I want to share with you is if we have a model, really a full model is called a complete second order model. So if we have more than one predictor, then really we have more than just those two terms, one for each predictor. We actually have what they call quadratic terms, where you multiply the predictor by itself, which would be like an x squared. And you can see that here. And then we have what we call interaction terms. And that is where I take the first predictor and I multiply it by the second predictor. So right now, we are just looking at a model. I can't highlight just part of it because this is an equation. But I believe, yes it is. Right now, all we've done so far is we've had y equals beta naught, which is our y-intercept, our first predictor, and then our second predictor. That's all we've had. And then, like, if we've had 5 predictors, like, you would have 5 of them. But if we only had 2 predictors, that's what it would look like. We wouldn't have all of this other stuff. This is called a better model. This is called a full second order model. I shouldn't say it's a better model because I don't know if it's better yet, right? Having those extra terms, the quadratic term, interaction term, it might explain some of the variability going on, and it might not. If it doesn't, then it just means it doesn't need to be in there and it's not significant. And if it does, then that's a good thing. Then that means that it's helping the model. So in this case, we're not going to talk about really much of like when to add the quadratic terms or when to add the interaction terms. I have it in here. I don't want you to worry about that because we never worry about that. I'll just tell you what to add and when to add it. And then I'm going to go over the process of how to eliminate terms. So normally what we do is we start with a full model, or I tell you, or I might say call it a partial model. So I might just say, okay, well, build the model with the addition of like the interaction term and not any of the quadratic terms kind of thing. So I never give you like a problem and then expect you just to build this full model from it, this full second order model. I never expect that. I've never expected that even before this semester. So I don't want you to think it's something new just for this semester. So a quadratic term, I'm just going to just go over it real quick. It's useful if the scatter plot indicates a curve or the residual plots indicate a curve, because what we want to do is we're hoping that the quadratic term would explain some of this behavior. So you can see the ideas of like what we're talking about here. Okay, that's when a quadratic term is helpful in our model. Then an interaction term, so that's like x1 times x2, that is helpful in the model if we have that multi-collinearity. Remember I mentioned that last week, when we have the matrix plot and we can see, or even the correlation plot or the correlation matrix, and predictor with predictor is strong. There's a strong relationship, so strong linear relationship between the two. So that's when we would have the interaction terms. We think we would explain some of that. Or here, if we have a scatter plot with the dummy variable and it shows that the slope change is different between the two colors, the zeros and ones. Oh, shoot. I didn't mean to do that. So right here is what I'm talking about. So you can see like, oh, okay, we have a negative slope for the blue, and then it looks like it might be positive for the red. That's when that interaction term might come in handy. Or like on this one, look at this, the multicollinearity right here. So this predictor with this predictor, look how strong that is. I don't want you to worry about that. I'm just telling you when those would be helpful in those cases. You don't have to memorize that. It's just nice to understand and know why we would build a model with more terms and not just those linear terms that we had. Okay. So when we're adding terms, I have this right here. I'm not going to go over it really right now because when we do an example, I'm going to show you. It just tells you step by step how in Minitab, when you're building your model, where to go to add like an interaction term or a second order term. But building the better model comes in here. So we have these rules that we have to go by. And all the rules say is that if I have a term that's either an x squared, so second order, or an interaction where it's like x1 times x2 term, then I also need to have the individual terms in the model. So say I have x1 times x2 in my model, then that means that x1 by itself as a predictor and then x2 by itself as a predictor both have to be in the model individually. So I can't have like a predictor part of an interaction or second order if it's not in the model. And the reason why that's important is because when we get into this model building here in this next section, we're actually going to take we're going to take terms out and we're going to take predictors out. And if I have like an x1 with an x2 for an interaction term, I can't take x1 or x2 out of my model, even if they are not significant. So we just need to keep those rules in mind when we're doing this. So the model building procedure, we're going to build the model how we're told. So you're going to see in today's example, I'm going to say, okay, let's do a regular regression model. And then we're going to do another model where it's a regression model with some interaction terms. We're going to add those in. I'm going to show you how to do that. Then I want to see, is the model statistically useful? Because if it's not, there's no reason to move forward and remove terms. I want it to be useful. I'm hoping that it's useful. And this is all stuff that we did on day 24, so last week. If it's useful and I'm going to keep moving forward, I want to make my model better though, as I'm going to look through my individual predictors and see if anything is insignificant, meaning that the p-value is greater than 0.05. So I'm going to look at those predictors and I'm going to take the predictor that has the largest p-value and I'm going to remove it, but I have to abide by my rules. So right here is part B. Is the predictor involved in a quadratic or interaction term? If it's yes, then it cannot be removed from my model. If the answer is no, then I could go ahead and remove it. Then after that, I'm going to build my model again. So I'm going to go back into my model making. So that's that regression, fit regression model. I'm going to go in there, I'm going to go into the model, I'm going to show you how to do this. I'm going to remove that term, I'm going to click OK to rebuild the model and get a new ANOVA. When I get that new ANOVA, then I'm going to study everything all over again. I'm going to look at all the p-values. You do it term by term, so one at a time. You don't just remove a whole bunch because the model changes just by removing one. So I'm only going to do one at a time, and in this test, in this process, I want to say, not a test, in this process, we use alpha of 0.05. The reason why we're going to use alpha of 0.15. The reason why we're going to use a 0.15 because we're going to like kind of loosen up a little bit. We don't want it to be so strict because 0.05 is really small. So we're just going to kind of loosen up a little bit and say, okay, if it's less than 0.15, then we can say it's significant. Okay. All right. So that's that. And we're going to keep repeating until all my p-values are less than 0.15. That's what we're going to do. So what we want to do when we're building the model, we want to make a note of what S is, right? My standard error of the model, and our R squared adjusted. We want to know how, good the model is for predicting. We're hoping that the R squared increases, right? That should increase. The more it increases, the more we're explaining that variability, the better the model is. That's good. And standard error, we want the standard error to be smaller, right? So if we can decrease that, that is good. So we kind of just make a note. You can write them down or just look at them, and we make a note of what they are. And hopefully when we change our model around, it will change those for the better. Okay. Then if I want you to do residual analysis, you do it on what we call the final model. Okay. I think we just go into not our Minitab, but our examples here. So I want to also mention, we're going to do this both ways, that Minitab can do this for us. So we're going to do it by step for ourselves, and really see what the process is. And then I'm going to show you how to have Minitab do it for us. And Minitab will give us all the steps that it did, and you can look through that. When it comes down to like the final exam, and this kind of stuff's on the final exam, you can use either method you want. If you want to do it by hand, or the step by step, or if you want to, I don't want to say by hand, but you do step by step yourself, or if you want Minitab to do it, it doesn't matter to me because you're getting the same results in the end. Okay, but I like you right now to at least see both, and I think on the daily I asked you to do both. I can't remember exactly. All right, so I'm going to take a look at the example for today. So today we're looking at this gas mileage example. So researchers interested in developing a model that describes gas mileage measured in miles per gallon of automobiles based on the input of an engineer. So we want to look at engine size, curb weight, and horsepower, and if the automobile is 2- or 4-wheel drive. So that my 2-wheel and 4-wheel drive is going to be my dummy variable for my zeros and ones. Okay, so 0 is 2-wheel drive and 1 is 4-wheel drive. So we have a random sample of 13 automobiles that she obtained. Okay, so we want to work through this. So the data is under our daily. I'm going to switch over to Minitab now. I already brought in my data, so go ahead and do the same. And you can look at this. Now I want to show you, and I mentioned this last lecture, I have a categorical or dummy variable here. It is not coded as zeros and ones. I need to do that. So I'm going to do that first. I don't have to do it right away now, but if I do it now, it's just done with and I don't forget about it, so I'd rather do it. So I'm going to go to data, recode to numeric. Now I'm going to tell Minitab which one I want to recode. That is my column 6, my 2-wheel and 4-wheel drive. And the method is I'm going to recode individual values. So I'm going to tell it, oh, my computer's just kind of having a fit. We said 2-wheel drive was going to be 0 and 4-wheel drive was going to be a 1. It's always zeros and ones. Okay, we don't go from that. We don't, go away from that. So it's always zeros and ones. And that's it. So I'm just going to click OK. It's going to make a new column. It will leave my old column. So my recoded. At this point, you could delete this column if you want. I'm going to delete it. I don't need it. There we go. And now I just have the dummy variable recoded as zeros and ones in here. Okay, so let's take a look at our matrix plot. So remember with groups, because I have that categorical here, I'm going to put my Y in first, which now I didn't label it, but it's my miles per gallon. I'm going to put that in first. Engine size, curb weight, horsepower, and then down here for categorical, I'm going to put in my 4-wheel or 2-wheel drive. My matrix options, I'm going to choose upper right and then click OK. So hopefully we can take a look at that. Sorry, sometimes this is a little slow. It doesn't look great, right? The reason why it doesn't look great, I only have 13 data points. So it's hard to really get an idea of what's going on. This right here does look like a negative linear. This one's a little bit all over the place, possibly negative linear. Here I've got negative linear. Remember for this, I'm really just interested in this top row because that's my Y with each of my predictors. Okay, so I want to keep that in mind. I can't really tell. Maybe this last one has the strongest relationship, but I really need to look at my correlation. So stat, basic, go down to correlation. And remember I put Y in last, so I'm going to choose my X. Not my categorical one though. Oops, sorry, not my categorical one, which is the last one, and then my miles per gallon I'm going to enter in last. And ignore the graph because I don't need that. I just want the matrix of my correlation values. So it looks like horsepower with miles per gallon is the strongest at a negative 0.7. So let me go back. Oh, wrong one. Horsepower, it is this last one. If I kind of scroll this down a little bit, you could see it. Maybe. There we are. So it is this one right here. This one on the upper right. So it's my miles per gallon, my horsepower has the strongest. So as horsepower increases, my miles per gallon go down, decrease. It's really hard to tell because I only have a couple points of four-wheel drive versus the two-wheel drive. It looks like they're down lower, so maybe there's a possible separation. It's really hard to tell. When you make a statement, it's really based on what you see, just support your statement. So if you say it's really hard to tell, then it's really hard to tell. I might state that there is some sort of a separation since these three red dots are down here lower, you know, they're not scattered all over. So maybe there's a slight separation with that. But then I would definitely say that the strongest relationship is between horsepower and miles per gallon, and it's a moderate to strong negative linear relationship. Okay, so I'm just using those two to go on that. All right, so let's build our model. Stat, regression, regression again, fit regression model. So here, my response is my Y, that's my miles per gallon. My continuous predictors are all my predictors I'm putting here. My engine size, curb weight, horsepower, and then my categorical of two-wheel or four-wheel drive. So at this point, I want to just leave it as is. I don't want to change anything. I'm just going to build the model the way it is before I start changing my model up any. So I'm just going to click OK. I'm trying to think if I want to get anything else. I don't think so. I think we'll just click OK. And have our model built for us. So here it is. Here's my equation. Here's my coefficient. So when I say my regression analysis, that's just my equation. That's all I'm looking for. And now when I'm looking to see if my model is significant, I look here at my regression, the top line, 11.12 with a p-value of 0.002. Yes, it is significant. So that means that I do have some significant predictors, okay? And you can look through the list and look and see, oh, okay, horsepower looks like it's significant at 0.04, and my two-wheel and four-wheel drive look like it's significant at 0.009. So I guess we did see a little bit of a separation between the two-wheel and four-wheel drive in our matrix plot. Okay, so now what I want to do, I'm going to just look at, I got to scroll back up here. I'm going to look at the S, my standard error. It's 0.99, and my R squared adjusted, which is 77.13. I'm just going to think about those, keep those in my mind. I'm going to build a better model and see if it truly is better, because if it's better, my R squared will increase and my S will decrease. All right, so let's build a second model. So this was the same thing, what we just did, the same thing as last class. So now we're going to build another model. I'm going to go to stat, regression, regression again, fit my regression model, so same place. Everything should still be in there the way it was. I'm going to click on model. Now under model, this is where I can add terms or take out terms. So this is where I'm going to keep changing my model up. So what I want you to do is I want you to add a term, an interaction term for curb weight and horsepower. So I'm going to just click on curb weight and then hold down my control and click on horsepower. And right here you can see the top one says interaction. going to add it. And now you can see right here, curb weight times horsepower. That's what it is. It's multiplication. If I was doing my second order, it would be here. So if I wanted to do like second order engine size, it would be like engine size times engine size. That would be this one, but I don't need to do that. I'm not asking you to do that in this model. The other one I want to add in is engine size times horsepower. So again, engine size, and then hold down the control and highlight horsepower, and I'm going to add that. So I want everything in my model, my 4 predictors that I had before, and now I'm adding in some interaction terms as well. So now here's my new model. I'm going to click OK and OK again. I'm going to get that new model. All right, so it should everything should look longer, everything should be bigger because I have more terms. So looking at this, I'm going to look at my regression. Yes, 8.59 is my F. My P is 0.01, meaning it is still significant. That's good. Look at my S, 0.94. It was 0.99. That has decreased. That's a good thing. My R squared has increased from 77% up to 79. So that's good. So just putting in those 2 interaction terms, I explained more of my variation and in my errors. I've actually made a better model just by doing that. But I want to build the best model I can. And the best model I can build is taking my full model, or what we call a partial here, because I didn't add in every single term that could possibly in there. And I want to reduce it down to a model that only has significant predictors. So let's do that. So I'm going to take this ANOVA output, and I'm going to study this. So I'm looking for the largest p-value of my predictors. I have 0.22, 0.23, 0.36. Okay, so it looks like 0.36 is the largest, but it's horsepower. I have to think back to my rules. My rules say that I cannot take out an individual term if it is included in an interaction, and it is. It's part of 2 interactions. I cannot take out horsepower. So let's go down to the next largest p-value. So that's going to be my 0.23. That is curb weight. I cannot take curb weight out either because curb weight is part of this interaction term. Okay, those are part of my rules. Now I'm going to look at the next largest p-value, which is 0.22, and it's engine size. I cannot remove engine size because engine size is part of this interaction term. So I know sometimes this is like a pain, but you can start looking at them really quick. So now I want to go down to the next largest, which I believe is this 0.156, right? Is that the one? Oh no, I'm sorry. The one right below my cursor was covering it. My 0.221. So that's my curb weight times horsepower. That is the first term I'm going to remove from my model. I know I just added it. I'm going to remove it. So curb weight times horsepower. I'm going to go back into my model building space. And I am going to go back into model. And I'm going to click and highlight curb weight times horsepower here. And I will choose this red X, which will remove it. And you can see it's gone. So I'm going to click OK. I'm going to rebuild the model. I don't have to record anything here. You don't have to like paste your output anyplace. It's just going through all these steps. You might want to mark down like what you took out, anything like that. And I'm going to repeat these steps. Now I'm going to go through and look to see. I can take a look at my S and my R squared if I wanted. R squared has decreased and S has increased. So now my model is not as good. So let's take a look at my ANOVA. And I have a 0.66, a 0.72, 0.2, 0.1, 0.399. So I can't remove anything that is part of an interaction term. So let's see, it looks like the curb weight is the largest. And I can take that out because it's not part of an interaction term anymore because I removed that interaction term. So I'm going to take curb weight out. So I'll go back into my model and remove that. So go in here to model, curb weight, I'm going to remove it. Okay, and you just do one at a time. All right. Okay, good. My S has decreased and my R squared adjusted has increased, so that's good. That means I've made my model better. I still have insignificant predictors, so I need to take care of these. Engine size is the biggest one, but see how it's part of the interaction? I can't remove it. So then the interaction is actually the next. So I'm actually going to remove that other interaction. So stat, regression, regression, fit my model. Go back and model. I'm going to remove this interaction and run the model again. Okay. S has been reduced down to 0.93. That's even better. And R squared 79.67. So that's even better. So that's good. My model is significant. And look at this. All of my predictors in here now are significant according to an alpha of 0.15. So we've changed it to 0.15 at this point because we just like loosening up a little bit. We don't want to be so strict. So now I have all significant. So I built a really good model here. And this is good. I would use this for prediction because look at this. My R squared adjusted is greater than greater than 75%. So that's a really good thing. So now I've built a good model with all significant predictors. So I hope that helped with that. So that's doing it one by one. I say by hand, it's not by hand, you'd have a Minitab do it, but you're doing them individually. I'm gonna go back in and build my model the way it was originally because I wanna show you how Minitab can do it for me. So if we went back to the original model, I'm gonna show you I could do this. I could go to model and just do default. That was my original model. See with the 4, not with the interactions, just the 4. And then I could go ahead and add the interactions. So the interactions are, I have to look, curb weight and horsepower. Then it was engine size. I don't know, maybe I don't. Yeah, I do have to hold down the control. Engine size and horsepower. Okay. And I'm going to run my model. I don't have to look at anything because I already know what it looks like. But I have to get that set up and then I'll tell Minitab to go in here. And, oh, wrong one. Now I'm going to tell Minitab to do that for me. So I have my model all built. You could always go back in here and just check under model, make sure it has all of those predictors and all those interaction terms. It does. I didn't touch anything. I'm going to go to this one all the way to the right called Stepwise. When I click on Stepwise, this is Minitab's way of reducing the model and making it better. So my method, there's more than this, just this backwards elimination method. The backwards elimination is just the one I teach you guys. There's other methods, but we just do the backwards. So you can see the different methods. We're going to choose backward elimination because that's what we want to do. I need to go down here and change my alpha to remove to a 0.15, right? Because I'm loosening up a little bit and I want to just keep anything that is less than 0.15 instead of the 0.05 here. The very last option, I want to show the details for each step. This will tell me what Minitab did step by step instead of just giving me a final. I'm going to click OK twice. And now you'll see you'll get the same model that we just got, but I have a whole bunch of output here. Here's my step by step. So look at right here, step 1 is the original model, right? Step 2, now I have to look at what's missing. Look at this last line is missing, that curb weight times horsepower. That's what we did. We took that out first, right? Step 3, now that curb weight times horsepower is missing because we took it out in step 2, but now step 3, the new one that's missing is just curb weight, and that's exactly what we did when we just did it a few minutes ago. And scroll down here because I see step 4, then step 4 took out the engine size times horsepower right here. And you can see this is what's left, but if you keep scrolling down here, here's my model, here's my regression equation, okay, and my coefficients, and right here is my ANOVA. So it has my regression, my p-value of 0.001, and look at all of my p-values for each of my predictors. That's exactly what we just had when we just did it ourselves. it's not really, it doesn't really take that long when you do it by yourself. It's just I was talking you through it and showing everything. So it just seemed to take a really long time. But I'd like you guys to see how to do it on your own individually. It just makes it clear what Minitab is doing step by step. And that's all it's doing. It's just doing it for you. And I don't care if you want Minitab to do it for you, it doesn't matter. I just like you to see what it's doing. Okay, so we have all of these p-values, we have all these significant predictors. All right, I hope that helped. Please join our second hour of our class if you have any questions in our Zoom meeting, and hopefully I can answer any questions you may have. And I will talk to you guys soon. Have a great day.